morning, everyone. Welcome to yet another episode of Health Discourse with Sakshi and Sushant. So, folks, today we will be discussing something which we have been discussing for past 2-3 talks, and today we will be elaborating on what are the pros and cons of using continuous glucose monitoring for people with metabolic disorders, and also how these devices they are impacting our daily lives and how are they actually useful for you or not, right? So hi Sushant, good morning, welcome to this episode. I hope you're doing
Morning.
good.
Good morning. So you have taken a morning topic of how people play with their electronic toys.
Apparently yes. I would say that I mean I am actually surprised to see a lot of dollars are spent on the research and development of such devices without any substantiated proof or any evidence that they will actually work for a lot of people, and then they market themselves in a way that that this is the only solution which is going to help you out, right? So I believe that the science should do the talking. Let science do the talking, right?
Yeah,
So
yeah.
yes. So I think with this, would you like to add here something?
So first thing is let us start with basics. We know as per the latest data, around 101 million people in India are uh, diabetic. 136 are pre-diabetic, and this is only tip of the iceberg. So there are three times of this number is something which people are already developing diabetes and they do not know because a lot of these signals at a molecular level are asymptomatic, right? And none of these devices or diagnostic investigations can figure out that, right? Because there are no symptoms as of now, right? But there
Yeah.
are a lot of molecular dysfunction happening, which we are not aware of, right? So that is one aspect. So probably it is one of the biggest epidemic of chronic diseases which we are facing because again we all know the connection between metabolic disorders with uh, brain health, with cardiovascular health, with kidney health, right? And it's very clear. But and I'll just give you a probably visualization of pre 2015 era, right? And because I believe from 2015 onwards, this CGM came into being, and a lot of these things, a lot of
Yes, it was introduced during those times, and we have
yeah.
in the West specifically. And also, I would like to add here that okay, for the sake of all the people listening to this talks, here are some interesting stats that you could look at, right? So when we talk about diabetes in India, so approximately 8.64 lakhs people they're suffering from type 1 diabetes, right?
Yeah,
And
yeah.
the remaining out of 101
Uh,
that's million, right?
101 million.
101 million.
Yeah,
So the remaining are the type 2 diabetics, right? And if
yeah.
we go to the stats, how many of them actually are using the CGMs, if you have any data with regards to that?
So, in case of type 1 diabetes, I think it is 25%.
25% of the total population of type 1
Type 1
diabetes.
diabetes in India, right?
Yes,
We're talking of
yes,
India, right? And
yes.
type 2 diabetes is hardly 2 to 3%.
So, which is apparently not a very high market size. And then the market research forecasters, they say it's going to be $1 billion industry, whatever. So, I think there is some gap in the research.
Now, yeah. So that's why I'm coming to it. So again, let us go slowly and deep dive into the pre 2015 era, right? So, uh, what we as patients or consumer used to do is, we used to check our blood sugar level, we used to check our HbA1c level, which is, glycated hemoglobin, right? And if it's high, probably doctor would prescribe metformin, right? And under the assumption that metformin is going to suppress your blood sugar level, right? So again, high level of HbA1c, right? 7.5% and higher indicates that every year you're losing 100 days of your life,
Yeah,
right? Right? So it is nothing but your sugar, advanced glycation, and products stuck to your hemoglobin, right? Because
right.
sugar is very sticky, right? So glucose sugar is very sticky, right? So again, Obviously, there are a lot of reasons. There is a reason of high sugary processed carbs, simple carbs. That's a normal, that's a baseline intervention. People say avoid these things and have a lot of fiber. That's a basic thing what we say to regulate our blood sugar response. But again, metformin, people who are taking metformin, again, the function of metformin is it activates an enzyme called AMP kinase, right? And I'm going to AMP. You remember we spoke about ATP, ADP, AMP, adenosine
Yes,
triphosphatidylcholine
yes, we
monophosphate.
have
So,
spoken about
right.
it. Yeah.
So AMP kinase is what signals your uh, endothelial nitrox synthase, eNOS, right? Which is lining every endothelium cell, which is again coupled with endothelial cell. Endothelial cell is lining with every blood vessel, right? This eNOS is set to activate GLUT4, which is going to go to cell membrane, bind glucose, and clear it from the circulation, transfer to cells for the transfer storage energy. That's a typical way. But again, for this, you need a signal. That signal is nitric oxide, right? We discuss about nitric oxide also, right? So I'm not going to, probably I'm going to discuss later part of this discussion about NO role of nitric oxide, right? So again, if even if it is activating AMP kinase, right? If your eNOS, if there is a nitric oxide deficiency or eNOS uh, is uncoupled with endothelium cells, so probably it is not going to impact, and that's why you've seen a lot of people are recommended higher doses of metformin also, right? And the companies who are claiming, that have you got rid of medicine? It is very, anyone tell you to eat less carbs or eat a lot of protein. It is going to make you temporarily hive off medicine, but it is not the you cannot equate it to reversal of diabetes, right? There's nothing called a reversal of diabetes, right? So again, it is a misnomer that you have got rid of medicines, so uh, you have got
You're not
it's a
diabetic anymore.
right.
Yes.
So even if you're taking medicine, there's no surety that it is actually regulating your blood sugar response, because you have to understand this intracellular signaling, which stimulates nitric oxide production, right? So if it
Right.
is it is not these are few things which are not aware, right? So again, coming on to the 2015 and beyond era, like we have continuous glucose monitoring devices, which is there, right? And again, before that, I'm going to tell a lot of people that the food which we eat is first available to the microbes in our mouth, right?
Mm, mm,
Right?
mm, mm.
They metabolize it, and then they use those foods, to send biochemical signals via metabolites to various body organs, including pancreas.
Right.
Similarly, since genes inside our body, 99% genes expressed inside our body and microbial, so there's a limited capacity of human body to metabolize these foods, and a lot of these foods are metabolized by your gut microbiome, right?
Mm,
So
mm,
again, the now coming into fact that the CGM, what does it do, right?
right.
When you fix your CGM, it has a biosensor, which again is valid for 14 days, right? I'm going to discuss about the cost also and impact also. But
Yeah. Yeah.
so it is only for 14 days, and it tells you the blood sugar spike in response to a meal,
Mm, mm,
right?
mm.
So you don't say, if you are having, suppose you're having vegetables, kidney beans, rice, and curd, you're not going to say, I'm going to first eat curd and then kidney beans and then rice and then vegetables. It doesn't work like this, right? So you
But
take a minute.
Sushant,
Mm,
here's a
mm.
question. As per my understanding of the biology, it takes about 24 minutes for the food to reach the intestine, and it gets metabolized. It takes time. So approximately 6 to 8 hours is the kind of time that food
Yeah,
substrate.
yeah.
Yeah.
So I'm
So
coming to that.
how is it that the real time monitoring is happening? Because then that is not really possible if anybody even is claiming that it is real time happening. But biologically, that is not possible if you see it like that.
So yeah, that's I'm coming to that. So probably, first thing is that let's assume they are giving you real time uh, sugar levels, right? Again, they are giving for a meal, right?
Yeah.
What we need to know, not for a meal, but for each specific food substrate, right?
Mm.
So not even meal, not even a single food. You don't need to know, okay, if you eat potato and you have a sugar level spike, you will blame potato. You don't blame potato. You blame a specific substrate or molecule in the potato, because potato again would be a combination of 100 plus such molecules, 50, 100 molecules. So each a particular molecule would have a higher spike, a particular molecule would have lower spike, would have medium spike, would have low spike, number of things. So essentially, first is that the biggest flaw is that CGM would not tell you a spike in a particular food substrate, right? And again, the spike is linked to the inflammatory activities inside the body, which is again triggered out of a gut or oral microbiome. So if you're eating something, so you know what, that's what we have built when we have built the disease prediction model or your predictive glycemic response to 300 plus foods. We look at 17 inflammatory pathways, including oxide, including LPS, including GLP-1,
GLP-1, right?
uric acid, fructose metabolism, glucose metabolism, fructose
I remember it
metabolism.
was a very complicated model, and when the a team was doing the research, it took us like lot of time to, bring this model to precision, and yet a lot of a lot of people data that has been coming up with us. There's again
Mm.
the model is getting improved, and
Mm.
yet it is very surprising that the model has actually worked for people. We have seen that.
Mm.
Yeah.
Mm. Yeah. So again, so first gap is they're not telling the spike there. So there are certain you need to know. I have an inflammatory cascade inside the body that is causing because of particular food substrate, right? So that is missing. So you track your blood sugar response to a meal, not to a food, not to a food substrate. Second thing, as you rightly pointed out, that the absorption take 3 to 6 hours, right? So if you have put CGM in the morning, it is going to tell you probably what you ate at the night, response to what you ate at the night, not what you ate immediately before fixing, the CGM, right? So you
Right.
can't say I ate a sugary thing, or let's assume I ate a wheat bread, right? And it is spiking. So it is not going to give you the immediate response, because there is an absorption process, there is a digestion process, there is a lot of enzymatic activity which happens inside the body, microbial interaction happens, right? So it is not something which your CGM could. So it is not real time first thing. It is
Right.
not precise. It does not. So it does not answer the question that which specific food substrate it's causing. And the third and biggest thing is here, right? Is that again, when you start eating, because remember, you're feeding your microbiome, you're not feeding your body, right? So
Yes.
as you eat, your microbiome composition changes, your microbiome functions changes, right?
And it changes with time. It's not a
It
1 day or
changes.
2 day
Yeah,
thing.
so it
Yeah.
changes. Probably you fix CGM for let's assume 28, 30 days. And again, your response to food will again change because your microbiome function changes, right?
Hmm.
For instance, if you're eating red potato, it is going to have a medium spike early, but it is not going to spike now, or probably it is going to elevate spike. It depends upon every individual's biology, right? Different
Yes.
glycemic response, right?
Yes.
So,
Yes.
so essentially, again, you have to keep fixing this. It means that it is a part of your life. You have to keep it fixing and spending money. And coming on to money, every month I've done a research on this. So some companies give device free of cost. Some companies charge around 7,000, 7,500 bucks, right? Plus the biosensor is varying from 5,200 rupees to 6,000 rupees a month, or not a month, even one
For 14
biosensor
days.
for
For
14
that's
days.
for 14 days. Every 14 days you have to replace that thing.
Yeah, yeah.
Yeah,
So so
that's the strip actually that is
yeah.
getting replaced.
So
Yeah.
from 10 to 12,000 you are spending in a month on fixing your biosensor. You are just tracking, okay, my blood sugar is going high and up and down, right?
Hmm.
But
Hmm.
it doesn't tell you which specific food substrate. And again, it is guesswork, because again after a month, your recommendations will your insulin response to different foods will again change, right? So it is like a financial model for these GGM companies, right? Second thing is that, you know, these are OTC, these are not regulated, these are not approved, right? I think FDA has only approved Dexcom as
One
of
brand.
now, right?
One
Right?
brand is there.
Right? Any of the brands in India especially are OTC, right?
Yeah.
And they are not approved by even the Indian regulatory authority, right? So there's a question mark on the efficiency and on the precision as well. right?
Hmm.
Third thing, right? I'm going to tell you a very important thing, which happens deep on a cellular level, right?
Hmm.
So we discussed this that cholesterol is something, and the fat is something which is uh, which which our cell membrane that maintains the fluidity of cell membrane, right? So when you're
Yes.
taking a lot of seed oils, like when you're taking healthy snack sort of things, right? You'll say it as so we generally see what is the amount of sugar and blah 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 artificial sweeteners emulsifiers. We don't see the oils which are used to prepare those things.
Well,
And
apparently
again,
it's palm oil that is very much popular these days.
palm oil, seed oils,
Soybean oil and then
right?
cottonseed oil and then rice bran is the new kind of oil that is being popularly
Right.
used. So
Yeah,
yes.
so when you take this, it changes the structure and fluidity of your cells, right? And there isn't dysregulation intercellular signaling, so it doesn't produce nitric oxide production, right? So it would lead to insulin resistance, right? We discussed if there is no, I know probably GLUT4 is not activated, there's a high blood sugar response in the food, and then again pancreas sends and release more insulin, and this is a process where your pancreas become less sufficient to release
Hmm.
insulin, and that's how you attain insulin resistance. So seed oil would not spike your blood sugar level, right? But because of this cellular dysregulation, right, there is a lot of spike which will go on, right? And the most important thing is that uh, essentially, if you see food is spiking because of inflammatory markers, so you learn probably, you learn which specific food substrate is causing it. Again, it will change every time. So you really need to spend a lot of money on CGM to track response to a meal, right? You will
Hmm.
still do not know which food is causing, right? Or which food substrate is causing, which is more important, right? Because again, food ontology is a combination of 37 plus molecule, right? But again, another thing, even if your food is not spiking enough, probably medium spike or low spike, right? If if there is a nitric oxide deficiency, right? So GLUT4 is not activated, still your pancreas is releasing insulin, right? You will have hyperglycemia, hyperinsulinemia, and you will have insulin resistance. So what you really need to know is whether my body is producing enough nitric oxide to activate GLUT4, right? Whether, or there's a lot of inflammation going on, oxidative stress, which is causing, oxidation of tetrahydrobiopectin, which is again a cofactor which helps in production of nitric oxide, right? Or there's a lot of, inflammation happening, which is uncoupling endothelial nitric oxide synthase from the endothelium cells, right? And again, which is causing nitric oxide deficiency. Or you consuming too much of L-arginine, which is making nitric oxide synthase to produce superoxide, which causes oxidative stress, right? Another thing is important. So when you talk of high protein diets, I've seen a lot of people pushing high protein diets uh, for regulating your blood sugar response. Now, first thing is you need to know which specific amino acid you need, how much you need, blah blah blah, right? But essential point is there is a one specific amino acid tyrosine which we are consuming, and when you're consuming excess, your microbiome, certain bacteria converts tyrosine into precresol. Again, precresol is a pro-inflammatory metabolite
We
which
have
we do.
we have talked about it previously.
Yeah,
Precresol is related to kidney issues
yeah,
and
yeah, yeah.
a lot of other things.
So,
So
so again, it also impacts your insulin response because precresol suppresses GLP-1 production, right? And GLP-1 we know is required for regulating our satiety and blood sugar response. So if
hmm.
if you have low GLP, probably there's a lot of food craving and sugar pangs, and you eat more, and then again it spikes your insulin blood sugar response. So there are multiple things, So CGMs is for me it's a false promise, right? Until unless they bring unless they bring the precision. Understanding, probably which specific food substrate is causing, what is the inflammatory marker which is causing,
Yeah, I totally agree what you the points that you have made. Also, what I think is that even if you have a CGM and you have done every other test that are
Hmm.
available in the market, yet you're not able to understand the root cause of it, because it
Hmm.
all boils down to what is the root cause of that particular problem, right? Now, what happens is in the CGM, now there are two ways to look at it. Either there is actually a spike, right? Or there is a spike because of some other metabolite which might be, it is not necessary it's because of insulin, right? It could be any other metabolite or any other inflammatory marker that is
See
doing
that
it. Yeah,
that's the starting point, So
yeah,
the spike, the first thing is spike in the blood sugar. So spike is this is spiking your glucose level, or spiking your blood sugar response because there's some inflammatory markers, right?
yes,
There's some
yes.
pro-inflammatory activity which is causing it, right? Or
Mm,
as I mentioned, probably some things which is not directly, so seed oils, it is not directly impacting, but it's going to impact your insulin secretion, it is going to impact your blood sugar response, right?
right,
So
right.
again, there's an inflammatory marker which specific food substrate is triggering that inflammatory activity is important to learn, right? So again,
Mm,
when we take food, we take a meal, probably we know this particular meal is spiking. We don't know what specifically food substrate is spiking. So it's again a guesswork, right? So
right.
again, because of inflammatory, there would be a spike. That's what we tell. So that's what we tell that there's a regular spike, medium spike, high spike, elevated spike, super spike, right? That's what we decode when we see the microbial functions, right? Inside
Mm.
when we see either gut or oral microbiome both, right? So in oral microbiome we look at nine pathways. In gut microbiome we look at 17 pathways,
17 pathways, right.
right? So again, that is one aspect of it. A second aspect, even if it is not spiking, the thing is we have to see both at the cellular functions also. That if NO is not there, NO production is very less, so there's NO deficiency, right? Again, it is going to increase the circulatory level of glucose, and again there will be more insulin secretion, and again this all leads to insulin resistance, right? So it's not so simple, so linear progression that as we think that okay, we track your food response and it is enough, right? And we know this is spiking, so let me not eat this right now. Let me change this, right? And after 30 days, again, your microbiome response to food will change. Again, your spike level response to every food will change, and you would again you have to keep this. You have to spend 10 to 12,000 rupees a month, right? And that is one of the reason this is not growing, and how the money the VCs would pour into this. There is a lack of precision. There is it is not giving you a complete picture of your metabolic health because molecular cellular function has not been decoded, right? It is costly, right? It is not regulated,
Mm.
right? So there are multiple issues here, right? It would take, so it could be a good science going forward. So my objective is probably, even if you my request to everyone is, even if you're using it, let it not be a starting point,
Mm.
right? Your starting point should be understanding your molecular and cellular functions.
It is only good for experimentation. That is what I believe. Because if you know the starting point and if you want to see that, okay, this is the kind of metabolite which is working against my body, and if I want to fix it, I want to know that, okay, what is happening. So that these things should be used at a later stage when you are actually in the process of fixing yourself, right?
Yeah, because see,
So,
even if it's spiking, it is spiking, but still, if you don't know your body is releasing good flow or not, right? Which is again a protein which clears the glucose of the circulation, right? So it is not going to help. Even if it's spiking more or less, it is still going to be in your circulatory system, and your body will still release more insulin, right?
yes.
Insulin is a hormone. It binds to insulin receptors on various cells, right?
Mm,
It
mm,
this triggers cascade of intracellular signaling. It activates AMP kinase, which tells your eNOS to release activate GLUT flow. To activate GLUT flow, you need nitric oxide production. If you don't have nitric oxide production, probably GLUT flow will not be activated. The food is spiking less or more, right? It is good to know this food is spiking less or more, probably. But if it is not, if your GLUT flow is not going to clear up the circulation, so you need to know whether your body is actually activating GLUT flow or not. So there's NO
right,
production. And again,
right.
oral microbiome become more and more important because as we age, our endothelial cell ability, which uses oxygen as a oxygen oxidized L-arginine is a substrate which is a semi-essential amino acid produced inside the body to produce nitric oxide, right? So that the ability of our bodies to reduce it goes down, right? So we rely on oral microbiome.
Yes, I agree. So I think with this we have come to the end of this discussion. So Sushant, any any last words would you like to add to this?
Yeah, so a few things more you have to consider. You have to also consider your toothpaste. You have to also consider if you're using mouthwash, right? Certain sugary things which is going to disrupt your oral microbiome as well, right? Check on your snacks which you're eating. The so-called prefix healthy snacks would be, would do more harm than good, because if there's a lot of seed oils and all these processed oils, which is going to disrupt your cellular signaling, and is going to display mitochondrial cell production or glucose activation, right? Or even mitochondrial biogenesis. So it could lead to mitochondrial dysfunction, which again is the reason for type 2 diabetes, right?
Yeah. So thank you, Sushant, for such an insightful discussion. And I believe people will definitely benefit after listening to this. So for all our followers and listeners, please, thank you for listening to our podcast time and again. And we keep listening to us. Please share this video. Please share the podcast with whomever you think they need. And thank you. Thank you, everyone.
Thank you.